A very good morning, good afternoon or good evening to all my dear students. Welcome to my channel Enjoy Learning. In this video, I am going to tell you 5 more amazing tricks that you can apply by solving the problems of inverse trigonometric functions. I have watched part 1 of this video in which I have taught 5 new and amazing tricks. But before beginning, let me remind you of 2 things. You have to be tension free and second, be focused. So let's begin with the trick 6 for type 6. So the type 6 questions are, you have to evaluate the value of this trigonometric function. So here the trick that you have to use is to let the inverse trigonometric function. You have to let the inverse trigonometric function. See, sine theta, this is such a complicated angle. So in order to simplify it, you just let this the inverse trigonometric function. In all such examples where you get an inverse function in the angle, see sine, and inside the bracket you are getting an inverse function. You just let the inverse trigonometric function and your question will be simplified. Let's see how it works. Let sine inverse minus under root 3 by 2 is equal to theta or x or y, whatever you want to let. Then second is minus under root 3 by 2. Now sine inverse will move from LHS to RHS and will become sine. So this much. Sine theta is equal to minus under root 3 by 2. Now let's see here. What we have done, in place of sine inverse minus under root 3 by 2, can we write theta? Yes, of course. So let's write. Now see, sine pi by 2 minus theta is cos theta. This is an identity. Sine pi by 2 minus theta is equal to cos theta. It's an identity that you have must learnt in class 11th. Okay, so here you have sine theta. Value of sine theta is given and you have to find cos theta. So cos theta is equal to under root 1 minus sine square theta. This is again from an identity studied in class 10th. It's sine square theta plus cos square theta is equal to 1. So sine theta is equal to 1 minus cos square theta under root. Similarly cos theta. See, your question has simplified to such a great extent. Squaring minus under root 3 by 2 will give 3 upon 4. This is equal to 4 minus 3 is 1 upon 4. This is 1 upon 2. So what you have done? You have just let the inverse trigonometric function and see, your question has simplified to such a great extent. This is how you have to perform in the second and third examples. Let's take them up. In this question, you will let cos inverse 4 by 5. There is one more trick in these two questions. See, so now 4 by 5 is equal to cos theta. Now let's see here. What you have got? In place of cos inverse 4 by 5, we can write theta upon 2. Theta upon 2. Now you have to find sine theta by 2 when cos theta is given. See, means cos theta is given and you have to find sine theta by 2. The angle has changed. Here the angle has remained the same. So here the identity that you have to use is very important. It is under root 1 minus cos theta upon 2. You have to memorize it. when cos theta is given and you have to find sin theta by 2, then you have to use this formula. Okay. Now just put the values and get the answer. 1 minus cos theta, that is 1 minus 4 by 5 upon 2. It is under root 5 minus 4 is 1 upon 10. This way you can get this answer. Now example 3 also, you will get to know about a new identity. Again, let cos inverse under root 5 by 3 is equal to theta. So under root 5 by 3 is equal to cos theta. Okay. In place of this, you can write theta by 2. Now you have to find tan theta by 2 when cos theta is given. So here the identity that you have to use it under root 1 minus cos theta. See, cos theta is given. So you can use this identity upon 1 plus cos theta. Just memorize all these identities. When cos theta is given and you have to find tan theta by 2, then the identity is 1 minus cos theta upon 1 plus cos theta. One minus under root 5 by 3 upon 1 plus under root 5 by 3. Now this is 3 minus under root 5 upon 3 plus under root 5. Now what we have to do? We multiply it by its conjugates. See, 3 minus under root 5 upon 3 plus under root 5 into multiply by the conjugates of the denominator. Okay, 3 minus under root 5. 3 minus under root 5 upon a plus b, a minus b. Here you have to use the formula of a square minus b square. Upon 4. A square, that is 9, minus b square, that is 5. 9 minus 5 is 4. Similarly, if you get a question like this, cos 1 by 2, and in bracket you get cos inverse 3 by 4. Now here also a new identity is there. Here also you will let cos inverse 3 by 4. Okay, so then you will get cos inverse 3 by 4 is equal to theta. So 3 by 4 is equal to cos theta. Okay, and now this question has become, this is theta by 2. You have to find cos theta by 2 when cos theta is given. So here the identity is 1 plus cos theta by 2. This is the identity. For cos theta by 2, the identity used is 1 plus cos theta on 2. You have to mug up all these identities. When cos theta is given, then the value of sin theta by 2, tan theta by 2 and cos theta by 2. It's so simple, okay? So just learn it. These are all the identities which have been formed from the identities learned in class 11th. It is formed from cos 2 theta. Okay. Let's take up trick 7 for type 7. Here you will get questions of the form. Write the following functions in simplest form. Here you have to find the simplest form of the function. Simple, what you have to do is you have to simplify it. Means you have to get a numerical value of this function. Remove this tan inverse. Here in such questions, the trick used is you have to let the value of x. Let the value of x. In different questions, you give different values to x. So in such question, you have to let such a value of x so that it becomes an identity. For example, in this question, are you reminded of any identity that you have studied in class 10th or 11th? 1 plus x square. You just recall. It resembles 1 plus tan square theta is equal to sec square theta. And also 1 plus cot square theta. It means you can give x either tan theta, can give the value of tan theta or cot theta to this x. So here, since you are having tan inverse, so give the value of tan theta to this x. We give a particular value to x so that the whole or the part of this expression turns up into an identity. So here we are letting x is equal to tan theta. Now see, in place of x, when you will write tan theta, it will become 1 plus tan square theta, since x square is there. And then in place of 1 plus tan square theta, you can write sec square theta. This is the way how you have to solve it. In such questions where you have to write the simplest form, you have to remove this inverse trigonometric function and find a numerical value or a definite number only without any trigonometric or inverse trigonometric function. See, tan inverse under root 1 plus tan square theta minus 1 upon tan theta. You have to simplify it. Now see, in place of this you can write sec square theta and it will become sec theta minus 1 upon tan theta. Now how will you solve it? Just express these trigonometric functions in terms of sine and cos. Sec theta you can write it as 1 upon cos theta. So it will become 1 minus cos theta upon cos theta. When you will solve it, do it in your rough copy. Place of tan theta, we can write sine theta upon cos theta. See, tan inverse 1 minus cos theta upon sin theta. Okay, so now how you will convert this expression in terms of tan theta? Since in simplest form you have to remove this inverse function, and what is the way of removing it? You just know only one identity, which is of the form tan inverse tan x is equal to x. This is the way. You have to you have to bring up here tan, so that tan inverse and tan get cancelled up and you just get a numerical or a definite value. So though I will be making a new video on how to convert various expressions in terms of tan theta, which seem to be very different, see, but you can easily convert it into tan theta. Okay, I am telling it here also. But in the next video, I will take up many expressions and convert it into tan theta in the easiest way. Here, when you are getting any point what to do next, so you just need to put the value of cos 2 theta in place of this. Cos 2x you have learnt and sin 2x. If you get 1 minus cos theta, then you have to put identity of cos 2x. So you have to eliminate this 1. So you have to put the value of cos 2 theta accordingly. So here we will put the value of which is 1 minus 2 sin square x. Cos 2x is equal to 1 minus 2 sin square x. If you will put this identity, 1 will be eliminated. See? Here we have theta, so here it will be theta by 2. And in place of sin theta, put the formula of sin 2x. 2 sin x cos x. The angle gets just the half now. Now solve it further. You can easily get the answer. Let's take up the next type, which is tan inverse x upon under root a square minus x square. Here you are getting x other than the variable x, a new quantity a. So what to let in this question? See, here's as you have 1 plus x square, so you have put the identities, you have put such value of x so that it resembles 1 plus tan square theta or 1 plus cot square theta, those identities. And here you are getting a square minus x square or 1 minus x square. So here you have to put these identities. This identity, this single one. You have learned this identity in class 10th. Simply, you have to put either see, sin square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sin square theta. Does it resembles it? 1 minus x square theta, 1 minus x square theta, or in place of 1, if you have a, then it doesn't matter. Here you have to put either sin or cos in place of x. So first you need to check. First you have to find the express this function in the simplest form. That means you have to eradicate this tan inverse. Then second, to eliminate it, you have to find such a value of this expression so that it gets converted into tan theta. Then only this tan inverse along with tan theta will give theta. Then only you can eradicate this tan inverse function. So here, see, tan theta is sin theta upon cos theta. So if you will put in place of x sin theta, and by using some tricks, some tactics, convert this denominator into cos theta, then you can easily get tan theta here. Are you getting what I am saying? Okay, but now the problem of this a is just solved by whatever you let in place of x, either sin or cos. Just multiply it by a or by any other number that is given other than the variable x. So here we will let x as a sin theta. See, in place of x we will get here a sin theta. We can also let cos theta, but here we have not done so, since we have to convert it into tan theta. So tan theta is sin theta upon cos theta, and we can simply get sin theta here in the numerator. That's why we have done so. It is very simple. A sin theta upon under root a square minus, in place of x, a square sin square theta, since x is squared here. Now the question gets simplified. See, take a square common, then it will become a come out of the root. Inside we get 1 minus sine square theta. This is the way how you've converted such a complicated expression in terms of tan theta by letting the value of x. See, 1 minus sine square theta is cos square theta, and it will come out to be cos theta. Now here it is tan inverse sine theta upon cos theta is tan theta. It will give tan theta. Now, what important step you need to do here, and many students skip it really. Now you have to replace this value of x in terms of x and a. You have let it now. So, and you have to find the value of theta from this expression that you have let. X upon a is equal to sine theta. So theta is equal to, take this sine, it will become sine inverse x upon a. This is the way. Take this sine away from this theta, that means from RHS to LHS. So it will become sine inverse and get attached to the LHS. Okay, sine inverse x upon a. So this is an important step. You don't need to skip it, otherwise your marks will be deducted. You have to express this theta in terms of x, in terms of the variable that is given in the question. Okay, so let's begin with the trick 8 for type 8. In such way, here we have started proving type questions. So whatever you get here in place of the questions of this type, are you getting its cos inverse 4 by 5 plus tan inverse 3 by 5 is equal to tan inverse 27 by 11. So you just know the formula of tan inverse x plus tan inverse y is equal to tan inverse something something. This is the identity. But here you are getting cos inverse x plus tan inverse y. So what you have to do? You just need to convert whether it is sine inverse or cos inverse in terms of tan theta. Can you convert this into tan? Yes, of course, tan inverse. By using the triangle method. I am depicting the triangle method here, and you have to solve the question on your own. Here also, you have to convert this cos inverse function into tan inverse. So just let it. Four by 5 is equal to cos theta. So let this angle be theta. Cos theta is base upon hypotenuse. Okay. Base upon hypotenuse. This will be 3. When you will use Pythagoras, it will come out to be 3. Now can you find the value of tan theta from here? Yes, of course. It's perpendicular upon base. So theta will be tan inverse 3 by 4. See, theta was this and now theta is in terms of tan inverse. This is the way how you have to convert any form, any inverse trigonometric function is given. You can convert it into other inverse trigonometric functions by using this triangle method. Now the question is very simplified. You have to just prove in place of cos inverse you have find tan inverse function. Now by applying the formula of tan inverse x plus y, tan inverse x plus tan inverse y, you can prove it. Let's take up the next type, which is questions where you have only sine inverse and cos inverse functions. Then it will be really very hectic to convert all these functions in terms of tan inverse in order to use that identity tan inverse x plus tan inverse y. So here a simple step goes as, you just let this sine inverse 3 by 5 as x, this as y, then your identity will become x minus y is equal to cos inverse 84 by 85. So now if you will take this cos inverse, it will become cos. So see, if you prove cos x minus y is equal to 84 by 85, then your equation will be proved. You can prove it. This is the way how you have to do it. Just let the sine inverse function or the cos inverse function, whichever is given, as x and y, and then what you have to prove. Take this cos inverse from RHS to LHS and find cos x minus y. You must be knowing this identity. It is cos x cos y plus sin x sin y. And prove it to be equal to 84 by 85. Then your equation will be proved. Here are the two different ways. First one, you have to use the triangle method. In the next one, the formulas cos x minus y and sin x minus y. You have to use these formulas. Cos x minus y and sin x minus y. These are also very important. Let's begin with the trick 9 for type 9. In such questions, here instead of getting a direct numerical value along with this inverse function, you are getting x. Now you have to prove it. How to prove it? It really sounds to be very complicated, but it's really as easy as it can be. See, you just have to let the simple inverse trigonometric function. Comparing these two, which one is the simplest one? This one, tan inverse under root x. So just let tan inverse under root x is equal to theta or y, whatever you want to do. Then under root x is equal to tan theta. And if you square both sides, then you get x is equal to tan square theta, isn't it? X is equal to tan square theta. Now just put this value of x in the RHS. You have let the simplest inverse trigonometric function and then put the value of x in the RHS. Then your question will be simplified. Now what you will get here? Half cos inverse 1 minus tan square theta upon 1 plus tan square theta. This is the formula of cos 2 theta, and then cos inverse and cos will get cancelled up. Just try it on your own. It's really very simple. Try it just now. The trick is, I have just told you the trick, the very important trick. This question seems to be so complicated, but it's really very easy using this trick. Similarly, in the second one, see this question, what it sounds to be. You just have to let, which one is the simpler one? Inverse trigonometric function. No, this is very complicated. This one is. So let it. We have let cos inverse x square is equal to theta. Now x square is equal to cos theta. See. X square is equal to cos theta. Just put the value of x square as cos theta and then multiply with the conjugates or what you have to do. It's really very simple now. Now just try it on your own. Then this trick 9 is that you have to let from the question itself. The simpler one, the simpler inverse trigonometric function, just let that, and from that trigonometric function get the value of x and put it on the other side. Put it here in the LHS in this case, and then you can easily prove this LHS to be equal to the RHS. Try it on your own, or else find the solution of this question at the end of this video. Okay, so let's take up trick 10 for type 10. Solve for x. This is the trick for solving type questions. See what's it. In these questions, you have to remember all the identities of class 10th and 11th. I am repeating it again and again because they are really very crucial for getting, if you want to get 100 on 100. Or if you want to get full marks in this chapter, inverse trigonometric functions. They are really very important. Along with the class 12th one, 10th and 11th are also very important. Let's see. Here you have 2 tan inverse cos x is equal to tan inverse 2 cosec x. This equation is given to you and you just need to find the value of x. So here you are getting, let it be theta. Let's assume it. And you have to put here the formula of 2 tan inverse theta. Have you learnt it? It's the identity of class 12th only. 2 tan inverse theta. The only thing you need to understand is you have 3 identities for the same function. So which one to put here? See, on the other side you have tan inverse. So put the identity of tan inverse. It is also equal to tan inverse 2x upon 1 minus x square, isn't it? It is also equal to sine inverse 2x upon 1 plus x square. But you don't have to put this value, because here on the other side, on the RHS, you have tan inverse. So you have to eliminate this tan inverse with the tan inverse when you will what you will get here. You have to make the two inverse trigonometric functions on both the sides same. Just keep it in mind. You have to make both the inverse trigonometric functions on both the sides of this equal to sign same. That's why you have to put the formula accordingly. Okay, so let's see how it works. 2 tan inverse cos x. Put the formula of tan inverse. This one. This one. It is tan inverse 2x. Here in place of x, what you have? Cos x upon 1 minus x square. First, we are solving LHS. Simplifying LHS. Now see, it's really very simple. If you keep in mind these tricks. In place of this, you can write sine square x. 1 minus cos square x is equal to sine square x. Now see. Cos x upon sin x is cot x into 1 upon sin x. 1 upon sin x is cosec x. Now just equate it with the RHS. It is tan inverse 2 cosec x. Now this tan inverse and tan inverse will be cancelled. See, this tan inverse will come from the RHS to LHS, it will become tan, and then using that identity tan inverse x is equal to x, both these tan inverse will be removed. I hope all this much is clear to you. Cot x is equal to 1. Now for which value of x cot is 1? It is pi by 4. This is the way how you solve this one. So the trick 10 only says that you have to, if you have the inverse trigonometric functions on both the sides of equal to, then in order to eliminate them, you have to make both of them same. Here it is 2 tan inverse. So you have to eradicate this 2. So you would put the formula of 2 tan inverse theta as tan inverse 2x upon 1 minus x square. Similarly, in the next question, there is one more trick. It is, here you have to find the value of x. So here what to do next? Here also you have to make the two inverse trigonometric functions involved in this equation same. Take this. As you do in linear equations, if you have to find the value of x less than x plus 2 is equal to 5. So what you do? You make x alone on one side of equal to and take up all the other numerical values to the other side. See, you do this. You take this 2 from here to here, it becomes minus 2. Simple. The same you have to do here. You will take up this cosec inverse function from LHS to RHS. here in place of cosec inverse 5 by 4, you can write sine inverse 4 by 5. Yes, you can. It's again an identity. Now pi by 2 minus sine inverse 4 by 5 is cos inverse 4 by 5. It's also an identity. Two identities. Pi by 2 minus cos inverse x is equal to sine inverse x, and sine inverse x is equal to cosec inverse 1 upon x. See what you have done here. Cosec inverse 5 by 4 is equal to sine inverse 4 by 5, this one. And in place of pi by 2 minus sine inverse x, you put cos inverse x. Now see, again you have to make both these same. That means you have to express this cos inverse in terms of sine inverse. Again you have to use the triangle method. See, triangle method is used wherever you have to convert any inverse trigonometric function into the other form. Just let it be theta. So 4 pi 5 is equal to, don't get confused, this is equal to cos theta. It's based upon hypotenuse and this will be 3. So sine theta will be perpendicular upon hypotenuse. So theta will be sine inverse 3 by 5. See, sine inverse x by 5 is equal to theta, and this is also equal to sine inverse 3 by 5. So you can equate these two terms. See, sine inverse x by 5 is equal to sine inverse 3 by 5. Now again both of them will be eliminated. X by 5 is equal to 3 by 5 and x is equal to, this gives x is equal to 3. Remember all these tricks. You can use the triangle method, the graph system, or you can use the identities studied in class 10th, 11th and 12th. Keep them in mind and you will be succeed. Okay, so thank you friends. Watch my upcoming video in which I will tell you how to convert many complicated expressions which seem to be very puzzling. How you can convert them in terms of tan theta. Okay, so watch it now. Thank you friends. Take care.